So yes, my name is Matt Biddulph. I am an unemployed data scientist. Thank you. So I'm going to try and hit you with a bit of data science and tell you some of the ways that I like to get into my data sets, tear them apart, find some insights within them. So every data scientist out there has their preferred way of thinking about data. So a lot of people think about data in rows and columns. So they might be a wizard with Excel and crazy macros. They might be putting their database into enormous MySQL databases, sharding them, analyzing them. Other people come from a mathematical background. They think of their data as matrices, and they use tools like linear algebra to decompose those matrices and find out the secrets hidden there within. But for me, naturally, as someone who comes from the web, I always think of my data as web-shaped, as graph-shaped. Whether it's stored in a piece of JSON somewhere, whether it's stored in a MySQL database, or whether I'm using a dedicated graph database like Neo4j, I always like to think of data as things and the relationships between things. And so obviously in this age of Twitter and Facebook, everyone's used to the idea that the social graph is a powerful way to represent real-world activity. And it's also a massively valuable resource, asset in its own right. And we can see why companies like Twitter and Facebook and Google are fighting over who gets to represent the social graph of the world. But this stuff actually goes back a really long way. If you look up social network analysis on Wikipedia, it goes back to at least the 1960s or 1970s, and it's a mathematical discipline which looks at social relationships in terms of a network theory, the idea that actors, people, nodes in a network are tied together by relationships, whether that's commercial relationships, social relationships. It's actually all about people and the connections between them. And there's a really deep set of mathematical theory that you can get into when you go and explore this discipline. So for example, there are centrality measures. So this is from the Wikipedia page on betweenness centrality. Betweenness centrality is a metric that says, for any person, anything in a network, if you need to go from A to B in a network, for example, if you need to get your message out to a person through the social network, the centrality measure tells you how likely it is that any random path through the network will go through a particular node. So the most central people in a network are those that are most likely to mediate the information flow. You can look at the structure of a network and try to find the communities within it. So because every network is made up of these nodes and these connections between them, you can look at the density of those connections and say, okay, there's a bunch of nodes over here, they're all more connected to each other than the nodes over here are connected to each other. And you can say that's community 1, that's community 2. And that was actually some of the earliest mathematical work that was done with pen and paper in the 1970s, studying the social structure of, I think there's a classic paper on a karate club. So a bunch of people, they had a karate club, the teacher fell out with the venue owner for the karate club, and he decided to start his own school. About half the people went to the new school, and about half the people stayed in the karate club that was in the existing venue. And they were able to mathematically prove that the choices people made about which to go to which club or other, the split between the two down the middle of the club went down the mathematical line of least information breakage. So they sort of, you can mathematically analyze the structure without knowing that it's a karate club, just look at the mathematics of it, and determine some aspect of human behavior. And we've all seen things on sites like LinkedIn, this sort of almost magical mind-reading, people you may know. And these are implemented by looking at the social graph, walking around it algorithmically, and saying, okay, there appears to be a gap here, where otherwise there should be a very dense set of connections. So perhaps that person just simply hasn't added that LinkedIn connection yet, and I should suggest it to them. So, as James alluded to earlier on, I'm always interested in practical applications of this stuff. So, I had a problem. I was in a new city. I just moved to Berlin, just started to work for Nokia, and we needed to recruit new people for our team. And I know London really well, and I know San Francisco really well, but I didn't know Berlin very well. And what I wanted to know is, like, who should I start with? Who are the best people to have coffee with that will give me an insight into the social network of Berlin within the coding community? So, and I'm going to show you data screenshots here from a London equivalent. So perhaps you may even spot some of your own names in the data. Went to GitHub, wrote a little screen scraper. Found every developer in Berlin that listed, every developer on GitHub that listed their location as Berlin, and then built a graph from that. And then I set to it with all those tools, all those mathematical tools that I was showing you at the start of the talk. So this graph is laid out based on community affinity between people. It is colored based on the the betweenness centrality of the individual, and each node is sized by the number of incoming links, the number of people that follow that person on GitHub. And just make you feel a little dizzy for a moment. As we zoom into the graph, you can see there perhaps some of the familiar names of the London tech community. And as you sort of look around the graph, you find it's actually a social map of the London coding community. You can even see the sort of Perl island of the true believers who are still writing Perl, somewhere up in the left-hand corner. And they all know each other really well, so it's a totally densely packed corner of the graph. So I was talking about this with James and Stephen, and they said, well, you know, we're always interested in the real mix of factors that makes a great developer and makes a great developer community. And we know that there are all these things that bind us together, whether it's love of beer, or love of coffee, or love of music. And so James suggested to me, well, you know, what is it about developers and dubstep, and what is it about certain communities of development, of developers, and they're kind of like whiny singer-songwriter stuff. You know, you hear different stuff in different coding shops. So I set out to prove or disprove the idea that music indicates developer community using data science. I only have a small run of data that I did amongst my own friends. I'm looking for some time to do a full crawl of the GitHub and Last.fm graph. But I ended up with this. So, and I'm going to zoom into this again a little for you. I created a graph. Rather than just saying who has followed who on GitHub, I looked for the implicit network of relationships between developers and music. So I tried to find every developer username on GitHub. I tried to match it up with the same username on Last.fm. And if the Last.fm API and the GitHub API told me that those usernames had the same name, like I happen to be Biddulph on Last.fm, I happen to be Matt B on GitHub, then I assumed that was the same person. Checked a couple of other APIs that try and do social matching to match them up. I then downloaded the list of what projects each person had done on GitHub, and I downloaded their top 100 artists. And so any time that and looked at the language choice for each project. So every time a JavaScript coder had listened to Rage Against the Machine, the graph ended up with a link between JavaScript and rap metal. And indeed, what we find, if we look in the top corner of the graph here, Ruby people, they're all like singer, songwriter, folk, you know, acoustic. Get down into the JavaScript rock quarter, however, and it's indie rock, it's alternative, it's rock. In the bottom right, people who put shell script projects on GitHub tend to go more into the electronic area. This is actually completely a non-statistically valid sample, but the methods are sound, I claim. So there's actually a really good book. If you're interested in these methods, and I'm going to go a little bit further into other things you can do with them, there's a really good book for O'Reilly that came out fairly recently. There's only two things wrong with this book, and they're both words in the title. There's nothing to do with startups in this book, in my opinion, nothing that's only for startups. This book is a set of techniques for looking at networks and analyzing things about them. And in fact, it's not specific to social either. This book is about network analysis, but that would have been a pretty boring title and probably wouldn't have sold as many books. But it goes through all these techniques and shows you using Python code how you can analyze a network, how you can bring in data from APIs, and how you can start to find things like the neighborhoods, the affinities, the central nodes in that network. And everywhere where you've heard someone talk about the social graph and the way you can analyze it, well, think about other graphs that could be analyzed using those same tools. So, you know, if I take the labels off the network that I showed at the start of a talk, which is people connected by friendships, well, what other kinds of networks could you build up from data that you have around the place? So when I was doing this work, I was working at Nokia. I was working in their location and commerce division. So what I had access to is tons and tons of data about place, but more importantly about people's relationship with place through their mobile phone. And I got really interested in what's the network of cities? What's the social network of cities? You know, if cities were people, would New York be better friends with LA, or would it be better friends with San Francisco? How can you work out these connections between place, bring them into a network, and then bring these powerful social network analysis tools to play on these structures that happen to have the same format? So I went to the Nokia Hadoop cluster in Berlin, and one of the things that they have there is every time every time someone buys a Nokia smartphone and starts using the mapping application, they're asked is it okay with you to use anonymous data to improve our service? So, and then from there on, every time you ask for a route from A to B, or every time you do a search for anything in the world using the Maps application on the phone, it's logged somewhere under an anonymous ID. And actually, as a side note, I should say I was incredibly impressed by their dedication to privacy. Such a dedication that it made it really annoying for me as a developer, actually. So, for example, when tracking where the phones are, when locking these GPS points, although they log a point every 5 seconds, every 50 logs, they completely randomize the ID. So you can't even trace someone throughout the entire length of their journey. So these anonymous IDs are constantly re-anonymized. But what you can look at, if you take these routing requests from A to B as an indication of intention, an indication of connection between two things, is you can start to build up a network. So let's say I'm standing here and I'm in the Holborn area of London and I need to get to Brixton. So I put into my phone route from Holborn to Brixton. In a very small way, in a tiny little piece of signal, that's saying there is a connection between Holborn and Brixton. Someone wants to go between those 2 points in the network. So I put in my graph database, I just put Holborn to Brixton gets 1 point. And if you load that up onto a Hadoop cluster and you do that across millions and billions of routing requests all over the planet by every Nokia smartphone, Nokia smartphones really do cover the entire planet over the months, then you can start to build up a new map of the world. And this is the real map of the world. You haven't seen it before. It's kept secretly inside Nokia servers. This is what happens when you make a graph of every request from any city in the world to any other city in the world by driving route, in this case. And then you lay it out, not using geography, but using the strength of the connections. So if you imagine every one of these cities is connected to every other city by a spring. And the more times people go from one city to another city, the stronger that spring is. Then you run a physics algorithm, essentially, and you see what shapes you end up with. And this is what you have. These are the true continents of the world, as decided by people who choose to buy a Nokia smartphone and choose to drive between two places. So, for example, Spain ends up being an island almost that drifts off. And the reason for that is that if you look at the map of Europe, although Spain is obviously a key member of the European Union, physically it's actually sort of on a peninsula almost. It goes off on the edge. So if you're driving between any 2 points in Europe, Spain and Portugal are essentially a sort of terminal node, an end of the line on that network. So they drift off, as opposed to, for example, Austria and France and so on, which are heavily integrated there. Now, that's intellectually interesting to me, and maybe we can start to build that into algorithms that will anticipate your needs a little better and make Nokia's phones a little better. But I think there's some really interesting questions you can ask of this data once you've got it. So imagine you're coming to London and you're a New Yorker. You're coming to London for a conference, and you don't really know London at all. You're like, where should I stay? So I know the conference is going to be in the Holborn area. And I don't really know London at all. I know that in New York, Times Square is the big, noisy, neon, safe commercial part of town. So I could ask someone. I could say, okay, I'm going to London. Like, what's the Times Square of London? And they could tell you, well, the closest thing's probably Piccadilly Circus. Then you could pick your hotel based on that. But what if you could interrogate the entire graph of everyone's decisions to go from place to place? What if you could ask, what's the Holborn of Amsterdam, or the De Pipe of New York, the Williamsburg of London? Start to find the communities and the affinities and the invisible maps of the world that are created not by geography, but by social activity, by performative information, rather than stuff that's explicitly declared or decided. So I guess what I'm saying here is the place graph is just like the social graph. Anywhere where you can see something that looks like a network, you can relabel things and think of it instead of as, here are people friending other people, you can think of it as, here are places with people driving between them. You could look at Wikipedia and all the links between every topic on Wikipedia and say anytime a Wikipedia editor writes an article that links from one topic to another, that's a connection in the graph. And once you've got a graph, you can turn 30 or 40 years of powerful mathematics on it. Find the hidden communities, find the key nodes, find out any number of things that were otherwise invisible before you thought of your data as a graph. Thank you very much.